Value of unknown charge placed at the centroid of an equilateral triangle. Value of unknown charge placed at the centroid of an equilateral triangle, and three equal and like charges placed at the three corners of the triangle at equilibrium. Value of unknown charge placed at the centroid of an equilateral triangle at equilibrium. In the diagram, ABC is an equilateral triangle. There are three equal charges, that is Q1 equal Q, Q2 equal Q, and Q3 equal Q are placed at the three corners ABC, and unknown charge Q4 equal capital Q is placed at the centroid D of the triangle. Here Q1 equal Q is one of the known charge. Q2 equal Q is also another known charge. Q2 equal Q is also another known charge. And the third known charge is Q3 equal Q. Q3 equal Q. And unknown charge Q4 equal capital Q is the unknown charge. Q4 equal capital Q is the unknown charge. Let Q1 equal Q, Q2 equal Q, and Q3 equal Q be placed. Q1 equal Q, Q2 equal Q, and Q3 equal Q be the like and equal charges. Be the like and equal charges placed at the three corners A, B, C respectively of the equilateral triangle. Placed at the three corners A, B, and C of the equilateral triangle. Of an equilateral triangle ABC. Of an equilateral triangle ABC. Q4 equal capital Q is the unknown charge. Q4 equal capital Q is the unknown charge placed at the centroid D of the triangle of the equilateral triangle ABC. Q4 is the unknown charge. Here Q1, Q2 and Q3 are placed at the three corners which are unknown charge and which are placed at the three corners ABC of the equilateral triangle. ABC is the equilateral triangle and known charges Q1, Q2 and Q3 are placed at the three corners. Unknown charge Q4 equal capital Q is placed at the centroid D of the triangle. Here D is the centroid. D is the centroid of the equilateral triangle. The net electrostatic force experienced by any one of the known charges, that is either Q1 or Q2 or Q3. The net electrostatic force experienced by any one of the known charges is zero at equilibrium. Net electrostatic force experienced by any one of the known charges is zero at equilibrium. But the electrostatic force experienced by the unknown charge under bracket Q4 equal capital Q is not zero at equilibrium. The electrostatic force experienced by the unknown charge Q4 equal Q is not zero at equilibrium. That is, the electrostatic force F1 experienced by this unknown charge Q1 equal Q is equal 0. That means at equilibrium F1 equal 0. F1 equal 0. Now the electrostatic force experienced by the known charge, Q1 at A due to another charge Q2 at the corner B of the equilateral triangle is F12 equal 1 by 4 pi epsilon 0 Q1 Q2 divided by BA whole square. BA whole square equal 1 by 4 pi epsilon 0 Q square by L square. Q square by L square. Therefore, F12 equal 1 by 4 pi epsilon 0 Q square by L square. F12 equal 1 by 4 pi epsilon 0 Q square by L square. In the diagram, we can denote the direction of this force F12. Q1 equal Q experiences a force F12 along AP due to the known charge Q2 equal Q at the point B. And this force F12 acts away with respect to the known charge Q2 equal Q. This force acts away with respect to the known charge Q2 equal Q from the point A. F12 acts along AP from the point A away with respect to the known charge Q2 equal Q, where the length of each side of the equilateral triangle under bracket BA, length of each side of the equilateral triangle is L, small is L, and BA equal L. Similarly, the electrostatic force on Q1 due to Q3 is F13 equal 1 by 4 pi epsilon 0 Q1 Q3 divided by CA whole square. F13 equal 1 by 4 pi epsilon 0 Q1 Q3 divided by CA whole square. Therefore, F13 equal 1 by 4 pi epsilon 0 Q square by L square. F13 equal 1 by 4 pi epsilon 0 Q square by L square. This is the electrostatic force experienced by Q1 due to Q2, and this force acts away with respect to the known charge Q3 equal Q, and it acts along AB, and it acts along AQ. AQ is the direction along which this force F13 acts. Now the force F13 acts along the direction AQ, and the charge Q1 equal Q experiences the force F13 due to the known charge Q3 equal Q. And this force F13 acts away with respect to the charge Q3 and from the point A. Again, the electrostatic force experienced by the known charge Q1 at A due to the unknown charge Q4 equal Q placed at the centroid D, that is the point D, is F14 equal 1 by 4 pi epsilon 0 Q1 Q4 divided by dA whole square 1 by 4 pi epsilon 0 Q1 Q small q capital Q divided by L by root 3 whole square equal 1 by 4 pi epsilon 0 3 capital Q small q divided by L square. So F14 equal 1 by 4 pi epsilon 0 3 capital Q small q by L square, 3q by L square, where dA, the distance of the corner A from the centroid D, is 2/3 AN. dA equal 2 by 3 AN equal 2 by 3 root over A B square minus BN square. the resultant of the forces F12 and F13 is given by F123 equal to root over F12 square plus F13 square plus 2 F12 F13 cos 60 degree. In the diagram, F12 is acting along AP, F13 is acting along AQ, and if we draw a parallelogram, in that case the resultant of these two forces F12 and F13 will be acting along the direction AR. F12 is the resultant force of the two forces F12 and F13, and this angle is 60 degree, and angle between F12 and F13 is also 60 degree. That's why you have written cos 60 degree here equal root over 2 F12 square plus 2 F12 square half, because cos 60 degree is half, and F13 is equal F12. F13 is equal F12 equal 1 by 4 pi epsilon 0 q square by L square equal root over 2 F12 square plus F12 square. Therefore, F123 equal root 3 F12. F123 equal root 3 F12. Root 3 F12, since F12 is equal to F13. So F123 is equal to root 3 F12, which is the resultant force of the two forces F12 and F13. This force acts along the direction AR. In the diagram, the force F12 is acting along the direction AN, and F123 is also acting along the same direction AR, and the resultant of these two forces is F1, which is equal to F14 plus F123. Now the resultant of the two forces F14 and F123 is given by F1 equal F14 plus F123, because these two forces F14 and F123 are acting along the same direction. That's why resultant of them will be F1 equal F14 plus F123. F1 equal F14 plus F123, which is the resultant electrostatic force, experienced by the known charge Q1, at the corner A of the equilateral triangle due to other charges Q2, Q3 and Q4. Due to the other charges Q2, Q3 and Q4 equal capital Q. At equilibrium, the resultant force experienced by the known charge Q1 at the corner A of the equilateral triangle will be 0. The resultant electrostatic force F1 experienced by the known charge Q1 equal Q, small q1 equals small q, is 0. At equilibrium, the resultant electrostatic force experienced by the charge Q1 will be 0. Therefore, F1 equals 0, or F14 plus F123 equals 0. In the diagram, F1 is the resultant force experienced by the charge Q1, and F1 is the resultant of F123 and F14. That's why F1 is equal to F14 plus F123, which is acting along the direction AY. Or F14 plus root 3 F12 is equal 0, or F14 equal minus root 3 F12, or 1 by 4 pi epsilon 0. 3 capital Q small q by L square equal minus root 3 1 by 4 pi epsilon 0 small q square by L square. Therefore, capital Q equal minus q by root 3. Capital Q equal minus q by root 3. Capital Q equal minus q by root 3, which is the unknown charge placed at the centroid, placed at the centroid D of the equilateral triangle ABC containing three equal and like charges. Unknown charge placed at the centroid D, q equal minus q by root 3, which is the unknown charge placed at the centroid D of the equilateral triangle ABCD containing three equal and like charges. Q1 comma q1 equal q, q2 equal q, and q3 equal q at its three corners A, B, C. At its three corners A, B, C. So Q1, Q2, and Q3 are the known charges placed at the corners A, B, C of the equilateral triangle. Unknown charge Q4 equal Q is placed at the centroid D. At equilibrium, net force experienced by the known charge Q1 will be 0. That is F1 equals 0. And here the net force experienced by this known charge F1 Q1 is equal to F1, which is equal 0 at equilibrium. And the value of unknown charge capital Q will be minus q by root 3. Capital Q equal minus small q by root 3.